Right, Mr. Holmes with another Zero to Hero video. I decided to break up the system software section into two parts. In this part we'll be dealing with the operating system. In my next Zero to Hero video we'll be dealing with the system application utilities, system utilities. Right, so without further ado, on to the main event. Computer systems, you should notice, are made up of two main parts, the hardware and software. There's a symbiotic relationship between these two, in effect. Hardware is the physical, electronics or mechanical devices that run the software instructions or programs in order to achieve some useful function. And we've already looked at this in some detail already in section 1.1, where we looked at the CPU and cache, section 1.2 where we looked at memory, and section 1.3 we looked at storage. So I will not say anything more about hardware. Software, however, is the section we now need to turn our attention to. Software is a logical group of instructions called programs or applications that use the hardware to achieve some goal. So it's important to notice that software does need the hardware to work, because you cannot have software existing without hardware. But the flip side of that is the hardware without the software is basically just a very expensive nightlight. It doesn't do anything particularly useful. So software is broken down into a number of different parts, two main parts in fact, namely application software and system software, which is the focus of the section that we need to study. But briefly, what's the difference? Well, briefly, application software is computer programs designed to perform a group of coordinated functions, tasks, or achieve some activities of benefit to the user or an end user. These will include things like your Office applications, Word processors, spreadsheets, and the like, graphical programs, and even computer games. System software, on the other hand, are more specialized. This is a special type of computer program that is designed to run the computer's hardware and application programs. So if we think of the computer system as a layered model, system software is the interface between the hardware and the user applications. This includes the operating system or the OS and system utilities. What do we mean by that? Well, here's the layer model of that we're talking about. So at the very top we have the user, which uses the end user will use their application software, and the operating system and the system software will sit between the application software and the actual hardware, making sure that the applications and the user is kept happy. So system software, it manages the computer's hardware, software resources, and provides common services to other programs and user interfaces. That's basically what we mean by system software. So system software manages the computer's hardware and software resources and provides common services for other programs and the users. So the most important pieces of system software is known as the operating system. Now, in the computing world, there are several types that you may have come across already. Examples include Windows, Mac OS, Chrome OS, and Linux. In the mobile or smartphone world, you would have come across Android, iOS, and Symbian. Right, so this section 1.7 in its entirety deals with the group of software that sits between the application software and the actual hardware. And this includes, as I've said, the operating system and other system software, which we'll look at in the next video. Right, now from our study of computer hardware and memory, you should recall that RAM is a very important resource within the computer's architecture, because all programs, data, and instructions need to be loaded into RAM for the CPU to actually operate on it. And in fact, the program that controls everything is the operating system. Now, because the operating system is so important, it has and also quite a big piece of software. Traditionally, this has been broken up into a number of different roles or sections. And in order to make the computer work as efficiently as possible, operating system designers try and keep what is known as the kernel, which is the core part of the operating system, as small as possible. The kernel, if you like, is that part of the operating system. It's the key part of the program that has to remain memory resident. So it has to remain in RAM. The operating system, through doing memory management and so on, might unload parts of itself that are not crucial for it maintaining its functionality at some point, and you probably will have seen this happen, where the systems got really overloaded, and then the first thing to go is actually the user interface, the display, because it's not as crucial as far as the operating system is concerned to keeping the display up to date as it is to make sure that the data and programs and files that are running are looked after. So effectively everything else in RAM will be dumped except the kernel at some point. But the kernel is that core part of the operating system that won't be removed from RAM. So formally, the kernel is the core part of the operating system that must remain loaded in RAM. These core parts include the application programming interface and the interface to device drivers. The kernel is responsible for multitasking, process control, exception handling or error handling, and interrupt processing. Right, so now we move on to looking at the 6 functions of an operating system as an overview, and then each one in turn in more detail. So in this respect, what we have, if you look at this diagram, you'll probably recognize some of this diagram. This over here, secondary storage to primary storage to the processor, input output, is essentially our von Neumann computer model. But to simplify things, instead of having an input coming into the processor and output, I've consolidated the inputs and outputs into a single block. So if you like, there are 3 functions that have a bit to do with the user, and 3 that have entirely everything to do with managing the computer system underneath it. Right, so my point of view is I like working from the user and drilling down, becoming more and more involved with the system as we go through. So at the very outside is the operating system provides the user interface. So picture a little man on a chair with two faces and an interface. So the operating system has to provide some way for people to communicate with the computer system and to be able to do stuff like launch programs and manage the files and so on. The second role that the operating system has is that of security. It has the job of protecting not only user data but core parts of the system to make sure that it's not compromised or abused. So this falls down to the this area of responsibility is known as security. Now, in addition to this, there is peripheral or device management. So I've got some spiffy new device that I plug into the computer system. The operating system, through use of device drivers, will be responsible for managing that new spiffy device and make sure that it works properly. Again, it's kind of a user-based role in a sense, because people tend to interact, and these are the bits you tend to notice. So to reiterate those 3 roles again: user interface, security, and peripheral device management. Now move on to the 3 more computer-based roles, and this starts from in the same order that we studied the hardware. We have process or task management, which is basically the operating system coordinating which programs are allowed to have CPU running time. In addition to that, the operating system is responsible for managing the computer's RAM, its memory, which involves managing what data and programs are stored in RAM, but also through use of a virtual memory manager, deciding how and when to swap things from primary memory to secondary memory, thus making use of virtual memory. And the sixth and final mechanism is giving and controlling access to the actual physical disk itself, which is what we call file or disk management. Right, so having summarized everything, we're now going to look at each of these functions in turn in a little more detail. Right, the user interface. The user interface provides a way for the user to interact with the system in order to manage files and launch programs. The user interface, or UI, is either a CLI, command line interface, or a GUI. Graphical user interfaces, or GUIs, are user interfaces, which is the user interface which we're most familiar with, providing the user with something called a WIMP, which stands for Windows, Icons, Menus, and Pointers. So the advantage of the system is that the user doesn't have to memorize commands. They just have to be able to apply some logic, point at the appropriate icons and double click, and program is launched, or files are copied, and so on and so forth. In contrast, much older operating systems and some server-based systems make use of a command line interface. In these, the user interface is purely textual based and command driven, so not very fancy at all. The user is required to know the commands and command words to use and to achieve whatever functionality they want. The advantage of the system, you might say, well, are there advantages? Yes, there are. The advantages of a textual or command line based system is that very complex processes can be scripted, and things, mass processing and batch processing can be taken care of much faster than you could by simply clicking on a whole bunch of icons, as you would in a graphical user interface. Right, so now we move to our second responsibility, that of security. Well, what is security? Security is the process of ensuring that the operating system integrity is maintained, that confidentiality and availability by controlling the user access to key systems or private data. This is implemented by providing authentication by login and applying user rights to protect access to files and folders. Security is the protection of a system from theft or damage to the hardware, the software, or the information in its entirety, as well as disruption or misdirection of those services for other nefarious purposes. So yeah, the job of the operating system is to make sure that everything is kept safe, nothing is abused, no data is lost, no data is compromised, no personal information is compromised, and so on and so forth. A collection of files, the user profile, is often what's created because we have multi-user logins. Multi-user operating systems these days, so multiple people can log in, and each user will have a user profile, which is a set of system files that stores their metadata about them, such as their desktop preferences, the recent history activity, and so on and so forth. User management, this is controlling access to the system and its files by using authentication and permissions. So when you log in, you'll be a member of a particular security group, and they will grant you rights or deny you rights to specific files and folders within the system. Right, peripheral management. What's a peripheral? A peripheral is a supporting device used to provide an interface to either an input and output from a computing system. And there are many. These include speakers and printers and mouse, keyboards, monitors, you name it. What's a device driver? A device driver is a computer program that operates or controls a particular type of device that is attached to the computer. A driver provides a software interface between the hardware device, enabling the operating system and other computer programs to access the hardware function without needing to know the precise details about how the hardware is being used. So, in the layer model, you can see that the operating system will hook in to the device drivers, and the applications will simply, by talking to the operating system, get the benefit of those device drivers. You might say, well, I don't have to install device drivers very often these days. Well, yes, you don't, because in most cases, the device drivers for most common devices are readily included as part of the operating system's device driver files. If you plug in a new device that the computer knows nothing about, you will indeed then need the device driver in order to make sure that that device works correctly. Right, task management. So our operating systems these days are known as multitasking. Well, let's get into what a task is first. A task is simply or a job is a term for a process or program being controlled by the operating system. And we know that we can have more than one program running at a time. We have multiple tasks running at the same time, and all those will be sitting in RAM. And the CPU can only run one of those tasks at a time. The operating system's job is to ensure that each of these tasks, each of these programs that are running, are given a fair slice of computing time. So the orange program will run for a bit, and then control will be passed over to the gray program. It will get some CPU time, and then the green program will get some CPU time, and so on and so forth. Multitasking is the role of the task manager that gives all the active running processes CPU time slices according to some algorithm. We don't need to know exactly how that's done and at this course. And basically your task will go into one of four possible states. They could be running, they could be waiting, they could be ready, or they could be completely suspended. Right, we now move on to the memory management part of the operating system functionality. The memory management is the process of controlling, coordinating RAM and virtual memory, assigning it to various running programs to optimize the overall system performance. And this is done, as we've learned already, by using a swap file or swap area. So this is a special file in secondary storage used by the virtual memory manager to hold instructions and data has been swapped out of RAM because RAM was full. The use of the virtual memory dramatically decreases system performance. However, it does give the system the illusion that it has more physical RAM than memory than it actually does actually have physical RAM. So it can do more, but at a cost to efficiency. The process is however completely transparent to the user and other applications, so the operating system manages all this. And as far as the applications are concerned, even if you've got 8 gigs of RAM, if you need more, your system will manage that for you. And finally, we look at the function of disk management or file management. File management is the process of providing the user and other system and other software access to the abstraction of files and folders, which the physical hardware saves as blocks and clusters. Okay, so let's talk about this. What do we mean by that? Well, you know from looking at Windows or Macs and through a GUI that we could perceptualize our storage of data in files and folders, and those in turn are stored in drives and hard disks and volumes and so on and so forth. That is abstract. That's a logical way of looking at it, and that creates a hierarchical directory tree. Apologies. Physically, this, however, is not how the data is stored. The data is stored as actual clusters. A cluster is a group of sectors which have been grouped together as a logical unit that the disk can read and write to efficiently. And these clusters are located in different areas on the disk, and files will use up a number of different. Each file will use up a number of different clusters. Now, those clusters can be located next to each other, in which case the disk will then be very efficient, or they could be split up and moved all over the disk for various reasons, which we'll look at in the next video. And this is what we call, when the files clusters have become separated from each other and are not continuous anymore, this is what we call a fragmented system. And the process of reversing that is called defragmenting. Again, we look at this in the next video. In order to use a disk, operating systems require that the disk is formatted. And basically what that means is it makes the secondary storage media ready to receive and store data in a logical manner determined by the operating system. It's useful to notice that the way a Mac would format a disk is different from the way a Windows system or even a Linux system would format that disk. So it does therefore mean that it's very unlikely that if you took a Linux-based operating system and this is partitioned in that way and you plugged it into a Windows computer, there's no way that Windows computer is going to be able to interpret that data correctly. Alright, so coming back to the 6 functions as a summary at the end. Yes, so 6 functions of the operating system: user interface, security, peripheral management, process management, memory management, and file and disk management. Thanks for watching. Mr. Holmes signing out.